Hello, let's start section 4.3, which is derivatives of natural log and exponential, or e to the x. So the derivative of natural log of x is 1 over x. Okay? So anytime you see natural log of x, the derivative of that is going to be 1 over x. Let's look at this example here. The derivative of x to the third natural log of x. So what I'm going to do is call, now this is a product, so we have to use the product rule. So call this guy f, this guy g, and we need to do f prime g plus g prime f. Okay, so let's write down all our pieces. F is x cubed. F prime, the derivative of x cubed, is 3x squared. G is natural log of x. And g prime is the derivative of natural log of x, which is 1 over x. Okay, so now we're going to do f prime g. F prime is 3x squared times g, which is natural log of x, plus g prime, which is 1 over x, times f, which is x cubed. Okay, now we can simplify this a little more. I know x cubed is the same thing as x cubed over 1. When we multiply fractions, we multiply straight across. So we leave this as 3x squared ln x plus x cubed. So this becomes x cubed over x, and that becomes just x squared. Right? So x squared. And that is my final answer. Let's do another one. So we need to find the derivative of natural log of x squared plus 1. Okay. So for this one, we're not going to use the chain rule. We're not going to use the product rule. We're going to use the chain rule because I have a function inside a function. So you can see that this is my inner function, right? And then this is my outer function. So again, we have to do the derivative of ln of something. So the derivative of ln something is 1 over that something, 1 over x squared plus 1, times the derivative of the inside. Okay, so times the derivative of the inside, which is 2x. So that becomes simply 2x over x squared plus 1. Okay. Again, the derivative of ln something is 1 over something times the derivative of the inside, which is 2x. So this here was the chain rule, and this here was the product rule. Let's do another example. So before I do an example, let me write down the general rule. So if you have the derivative of the natural log of a function, right? This is just generalizing the chain rule, or applying the chain rule to natural log. Then what you're going to do is take the derivative of the inside and then put the function on the bottom. Where is this coming from? This is coming from the fact that the derivative of ln something is 1 over that something, and then you have to do times the derivative of the inside, which is times f of f prime x. And then we can just combine that, multiply the fractions. Okay. So this is application or apply chain rule to natural log of a function. Okay. Let's do another example. I want you to differentiate the natural log of x to the fourth minus 1 cubed. Okay. Alright, so now we have a chain rule inside a chain rule, or a function inside a function inside a function. So the inner function, so we have x to the fourth minus 1. That's the inner function. Raised to the third power, that's the outer function, and then the most outer function is ln of that something, right? So let's do this. The derivative of ln something is 1 over that something. 1 over what? 1 over x to the fourth minus 1 cubed times the derivative of the inside. Well, the derivative of the inside is 3, so the 3 is going to come out front. You want to do minus 1, right? 3, leave the inside alone, raised to the second power, and then times the derivative of the inside of that, which is 4x cubed. Okay? So again, we have 3 pieces. We have, I can write this as f of g of h of x, right? Your h of x is x to the fourth minus 1. Then your outer function g of x is something cubed. Then your outermost function f is ln of something. Okay? So you start off with the outermost function, take the derivative of this first. The derivative of ln something is 1 over that something, right? 1 over that something times the derivative of the inside, which means now I have to take the derivative of this x cubed guy. So bring the 3 out front, minus 1, so we get 3, leave the inside alone, squared, times the derivative of the inside again, and that is 4x cubed. Okay. So let's simplify this. So 3 times 4x cubed gives me 12x cubed times x to the fourth minus 1 quantity squared divided by x to the fourth minus 1 quantity cubed. Okay. Now, when you're doing this, the first answer that I have written up here, that is an acceptable answer. Okay. But if I say simplify, or if you're checking your work in the back of the book, you'll notice they have simplified it down to simplest form. Okay. So now look at this. I have x to the fourth minus 1. I have 2 of those at the top, 3 of those at the bottom. So the 2 here will cancel out with 2 here, and I'll be left with 1 at the bottom. So that'll be 12x cubed divided by x to the fourth minus 1, right? And that is the simplified, or most simplified answer. Simplest form. Okay. Let's look at e to the x. So the derivative of e to the x is e to the x itself. Okay. Now if you want to see the proof of this involves using the limit definition, the limit of the difference quotient. Your book has the proof of how the derivative of e to the x is e to the x. Okay. This class doesn't cover that. We're just doing application, so let's do some problems. So let's do the derivative of e to the x over x. Okay. Now you look at this problem and you say, okay, oh, I have a quotient here, so I need to use the quotient rule. Oops, quotient rule. And so I'm going to call this guy f, call this guy g, and the quotient rule tells me f prime g minus g prime f all over g squared. Okay, so let's write down our pieces. F prime, or f rather, let's write down, start with f. F is e to the x, the derivative of e to the x is e to the x, g is x, that's the denominator, and the derivative of that is 1. Okay, so now I'm going to write f prime. F prime is e to the x times g, which is 1, that's lovely, minus g prime, oh, I made a mistake already, so you have to be careful doing it. f prime, so it's f prime is e to the x, g is x. That's times x. Oops, sorry. And then minus g prime, which is 1, f is e to the x. Okay? All over g squared, which is x squared. So we have f prime g minus g prime f all over g squared. So it's a good idea to map out, to do this mapping right here, because that'll help, especially when you go back and check your work. You can kind of check your work easily. So now we have x e to the x. We always write it as, this is standard mathematical form, you always write x e to the x instead of e to the x times x, minus e to the x over x squared. Then from here I can factor out an e to the x. I get x minus 1 over x squared. And that is simplest form, but either of these answers, either three of these answers is perfectly acceptable. Okay? Let's do another example. Alright. F of x equals x squared e to the x. Find f prime of 1. Okay? So first thing we need to do is find f prime of x. So f prime of x. Alright, so first this is a product, right? So I'm going to use the product rule. And let's see, f prime, well, let's start with f first. Let me call x squared as f. So f prime is 2x. G is e to the x. So g prime is also e to the x. Okay? So now we have, what does the product rule tell us? F prime g minus g prime f. Right? So the derivative of this big guy, this function, is f prime x. So this big guy, f prime x, is f prime, which is 2x, times g, which is e to the x. There should be a plus, sorry. F prime g plus g prime f. Plus g prime is e to the x times f, which is x squared. So I'm just going to write the x squared here. Okay? That's standard form. We write the e to the x towards the end. So I have f prime g plus g prime f. Okay? Now it says f prime of 1. So now every time I see an x, I'm going to plug in a 1. 2 times 1 e to the 1 plus 1 squared e to the 1. So 2 times 1 gives me 2 times e, so that's 2e plus e, right, plus 1e, which gives me 3e. Okay? And that is a constant. E is 2.71828. So the exact answer is 3e, okay? That is the final answer. And then I just want to show you that it is a constant. It's 8.15, blah, blah, blah. Okay? You don't have to do this. This is just some extra. But the exact answer is 3e. Okay? Alright, let's do another example. Okay, and if you have any questions, if you need to stop the video and pause it or replay it, please do that. Make sure you're understanding everything. If you have questions, contact me. Okay, so f of x is e to the x to the 4th plus 1. Find f prime x. So now, let me think. This is a e raised to a power, right? So this is e raised to a function. So a function raised to a function, I'm going to use the chain rule. Okay. So what is the derivative of e to the something? It's e to the something. derivative of e to the x is e to the x, so the derivative of e to the something is e to the something, times the derivative of the inside. So the derivative of the inside is 4x cubed. Okay, so the derivative of e to the something is e to the something times the derivative of the inside, or the inner function. The inner function here is x to the 4th plus 1, so we want the derivative of that, which is 4x cubed. And then we can write, we can simplify this as 4x cubed times e to the x to the 4th plus 1. That is my final answer. Or simplified form, rather, simplest form. Just like we had the rule for natural log of a function, right? We apply the chain rule to natural log. We can also apply chain rule to e to the x. So the derivative of e to the function is e to that function times the derivative of the inside times the derivative of that function, okay? Which could also be written as f prime x e to the f of x. Okay. Let's do some more examples. Find d over dx e to the x squared over 2. Okay, so you can think to yourself, okay, f of x, if I'm applying this chain rule here, is x squared over 2, which is 1/2 x squared. So the derivative of that is we pull the 2 to the outside, right? Minus 1. 2 times 1/2 gives me 1 x to the 1. Okay, so that's 2 times 1/2, which is 1 x to the 1. You can write out the steps in between. Okay, so then f prime x, so this is going to be f prime x, which is x times e to the x squared over 2. Okay? You're applying this rule. You can also think of it like this. Another way to do this is, what's the derivative of e to the something? E to the something times the derivative of the inside, which is this guy. That is the derivative of 1/2 x squared, which is x. Okay? So both ways are essentially the same. One, you're doing the chain rule in your head. The other one, you're using this formula in your head, which is just the chain rule. Okay. Let's do another example. Let's combine natural log and e. Okay. Natural log 1 plus e to the x. Okay. Now be very careful. Some people, I know people are going to make this mistake. They're going to think, oh, this is natural log of 1 plus natural log of e to the x, and then say natural log of 1 is 0, and natural log of e to the x is x, and call it a day. No, you cannot do that. Okay, this is wrong. Log of a product is the sum of the logs. Log of a sum is not the sum of the logs. Okay, so the only way we can tackle this is to actually go through and do the derivative. So what is the derivative of natural log of something? 1 over that something times the derivative of the inside, chain rule, derivative of the inside, derivative of 1 is 0, derivative of e to the x is e to the x, so this whole thing becomes e to the x over 1 plus e to the x. Okay, and that is our simplest form. Okay, so do more practice problems, as many practice problems as you can do. Okay, let's do an example. So after weeks, so this is example 9 in your book, section 4.3. After t weeks of practice, a pole vaulter can vault 15 minus 11 e to the negative 0.1 t feet. Find the rate of change, okay, find the rate of change of the athlete's jump. So when they say rate of change, we need to find the derivative. So we need to find h prime of t. So h prime of t, so h of t is 15 minus 11, let me write h of t here again, 15 minus 11 e to the negative 0.1 t. So the derivative of 15 is 0, okay, and leave the negative 11 alone. Okay, remember when you have a constant multiple, you leave that alone. And now we have the derivative of e to the something. The derivative of e to the something is e to the something times the derivative of the inside. Well, the inside is negative 0.1 t. Fix this. This looks like a division. The inside is negative 0.1 t. So the derivative of something times a variable is just like the derivative of 5x is 5x. So the derivative of negative 0.1 times t is just negative 0.1, because t is my variable. Okay, so the derivative of the inside is going to be negative 0.1. Okay, now be very careful. Don't be tempted to say, oh, this is my exponent, I'm going to bring the exponent out front and do minus 1. No, we don't do that with e to the something. You only do that when it's x raised to a power. Okay, and then the negatives cancel out. So I'm left with a positive. 11 times 0.1 gives me 1.1. So I'm left with 1.1 e to the negative 0.1 t. Okay, that is the rate of change for any time t. Okay, it says find the rate of change after 0 weeks, so at the beginning. So I have to plug 0 into here. That's 1.1 e to the negative 0.1 times 0. Okay. So we need to plug this in. So let me show you something. Instead of doing, let's see if I can move this over. Okay. Instead of actually plugging in the values, when you have multiple values to plug in, it helps if you use y equals. So let me plug this into y equals 1.1 e to the negative 0.1 t. I don't have t, I'll just use x. Okay, so that's my h prime of t. And then I'm going to go to second window, which is table set, and you want to make your independent variable be ask. Okay, change it to ask if it's on auto. Scroll down and hit enter on ask, and then we can go to second table and plug in values. If I can clear this. So let me do 0. Okay, and when it's 0, the y value is 1.1. Which makes sense, right? E to the 0 is, anything to the 0 is 1, so you're left with 1.1. Okay? And it says after t weeks of practice, a pole vaulter can vault this many feet. So your rate of change is, remember, rate of change is like your slope, y over x, y or h over t. H here is the height, so that's feet, and t is time, so that's weeks. So at the beginning, this pole vaulter rate of change is 1.1 foot a week. Right? That's how much that pole vaulter is improving. But after 12 weeks, hopefully they're getting better. Let's do plug in 12. That number changes to 0.33131. 0.33. Oops, let me write this. 1.1 e to the negative 0.1 times 12, which is roughly 0.33 feet per week, right? So after 12 weeks, they're jumping 1/3 of a foot higher than when they started at the beginning, right? So pretty much they're reaching their maximum that they can jump, and as time goes on, they're going to hit that ceiling. They won't be able to learn anymore or get any better, right? Just the limitations of human jumping ability. So so that is all of section 4.3. Please do the practice problems, the ones I have for you in the book. Aside from your homework are 7, 9, 11, 27, and 69. Okay? And if you have any questions, please get in touch with me and I will be more than happy to help you. Okay, thank you for watching.